This is a help video for your team test for ELO 2. This is ELO 2 team test video. ELO 2 is all about exponents and roots or radicals. Okay, this is number 1. I did it already, okay, because I don't really want to go over the the product rule again. So what I did was I simplified each expression down to its simplest form. This last one right here, you get a 36 in front instead of a 12. And the question, when you read it, is asking you to find which expressions give you a 12. So here, our 12 and our exponents are the same, but the problem when you go to simplify this one is you get a 36 here. So this doesn't work. The rest of them, they do work. So A, B, C, and D are all valid answers for number 1. Okay. Now let's get into talking about some of these questions. So number 2. Okay, number 2 has 6 total questions. I'm going to go kind of fast here, so bear with me. I'm using the product rule. So 5 times 6 is 30, and then I have 5 x's in total, and I have 6 y's in total. Here I'm going to use the power to a power rule. So 2 to the power of 3, x to the power of 9, y to the power of 12 simplifies down to 8. X to the power of 9, y to the power of 12. Okay, here I need to use the power of the power rule and the product rule. So I get 9 x to the 4th, y to the 10th, times 4xy. So that gives me 36 x to the 5th, y to the 11th. Here 48 over 6 is equal to 8. I have 3 x's on top, 1 on the bottom. This is the quotient rule, which means I have 2 left over. I have 5 y's on top, 2 y's on the bottom. Gives me 3 y's left over. Okay. This one, I have 6 x's on top, 1 on the bottom. So that gives me 5 left over on top. Here I have 2 y's on top, 2 y's on the bottom, so they cancel. And then I have 1 z on top, but 4 z's on the bottom, which means I have 3 z's left over on the bottom. On this question, you're going to want to take the negative exponents and make them positive. Flip it, make it positive. So right here, I get 5b to the 4th, b to the 6th, over 15 a to the 2, a to the 5. So now I no longer have negative exponents. This is the negative exponent rule. So that's going to equal b to the 10th over 3 a to the 7th. Please notice right here I have 5 over 15. 5 over 15 is equal to 1/3, which is why I got a 3 right here. And then I don't write the 1 in front of a variable. I don't write I don't write a coefficient of 1. Number 3, true or false? That fraction raised to the 0 exponent is equal to 0. This is false, because it is always equal to 1 with exponent of 0. Okay? So whenever you have an exponent of 0, it equals 1. This one, 7 to the negative 2 can be written as 1 over 7 to the power of 2. That's the negative exponent rule. Flip it, make it positive. Flip it, make it positive. So that's equal to 1 over 49. Flip it, make it positive. Okay. So here, you need to know the radical rule. Whenever you have a fractional exponent, that's the same as having a radical. So here I get 64 with a fourth root radical. I apologize, third root radical. Here you get 8 to the power of 2 to the 1/3. So this is 8 to the power of 2 to the third root radical. Okay, and here we get 9 to the power of 3 to the 1/2 power, which is 9 to the power of 3 square root of that. Now let's evaluate these. So square root of 36, that's easy, that's 6. Okay, here 64 to the third root is equal to 4. Right here, this would be 64 to the third root, which is the same as that question. So this one equals 4. Right here, 9 to the power of 3 would be 9 times 9 times 9. Okay? So this 9 times 9 times 9 would be 9 times 3, which is 27. Let's stop right here, talk about this. How did I do that? Here I have the square root. I could take out a pair. So every time you have a pair, you can take out that number in a square root. So that 9 gets taken out, and then the square root of 9 is 3. And so that's how I got the 9 times 3. Okay, simplify the following roots. Here you get 9 times 5, which is also 3 times 3 times 5. So I could take out the pair and do 3 root 5. Here I get root 6 times 10, which is also root 3 times 2 times 2 times 5. So I could take out the 2 root 15. Here I can get third root of 4 times 10, which is also the third root of 2 times 2 times 2 times 5. Here I need 3 to pull out 1 because it's a third root radical. So I pull out a 2, and then it's third root of 5. Okay, so those are my 3 there. Right? Here, I want to expand it out. So I get 2 times 2 times 5 times A times B times C, C, C. I could take out my pairs. Okay? So that gives me 2A squared times C, and then in the square root I have 5BC. Okay? Right here you combine like terms. So I can do 11 root 2's and then negative 2 root 5's. So this is the same as combining like terms, like if you had a variable. So anytime you have a root that is the same, you can add or subtract the coefficients in front of that root. Okay, this gives us 15 root 18. So whenever you can multiply radicals, you can multiply the coefficient and then multiply what's inside the radical, as long as the radical is the same root. So these are both second degree root radicals. And then 18 can be written as 9 times 2, so 3 root 2. Take that 3, multiply it with the, ooh, that's a mistake. 5 times 2 is 10. Sorry about that. But then 10 times the 3 gives you 30, and then I have root 2. Right? This one, simplify to 1 over 25, and then take the root of 1 and take the root of 25, which is 1 over 5. Okay? Awesome. That's the end of this video. If you want to see the 4th page, so the back page, I'm going to make a separate video for that because I want to talk about the extra credit problem. I think it's a pretty interesting problem. It's a question you'll probably see on your 11th grade state testing. So for your junior level state testing, it's a question you'll probably see. And it'd be pretty cool to get it right. Like, it's a pretty hard question. So anyways, I hope you enjoyed. Hope this helps. If it doesn't help, email me, come at intervention, whatever you need.